Hello everyone, I am Romit Kaware. Welcome back to the series on sediment management. In this module, we will understand the concept of sediment bearing pressure and try to understand its role in the sediment management. So this will be the around the flow of a discussion. So we'll start by building the idea of sediment bearing pressure, try to understand what does it mean, and the underlying relevance in the sediment management. So first, we must understand that the structure of the sea floor or the seabed needs to be understood properly. This can be done through the analysis of topography and the composition of seabed sediments. Now, this is, as we have already discussed, is like based on this concept of sediment classification. But with the very excessive economic activities going on, the vast economic potential of the Indian Ocean region, a lot of new activities are taking place. For this, we require a lot of offshore construction and exploration is going on. For example, oil rigs are there, various types of ports are there, offshore construction is being built on, and thus the effective sediment classification method should now estimate the sediment bearing pressure as well, including the strength and stability of the sediment strata. Now, one of the most significant applications of the acoustic seafloor classification is sediment bearing pressure. For this, the results of the sediment classification can be utilized, and we'll further see what all parameters would be necessary for understanding the sediment bearing pressure estimates. Sediment bearing pressure, it basically refers to the force per unit area exerted by the sediment on the surface it is contact with. Now it is generated when the sediment such as a soil or rock is placed on or against the surface and can be influenced by various factors like weight, the density, the moisture content of the sediment, also the shape and roughness of this surface of the sediment. This sediment bearing pressure, which can be the load carrying capacity of the sediment layers without excessive settlement, is very much crucial in the many engineering and geotechnical applications, which include the foundation design, retaining wall, soil stabilization. And thus, it becomes necessary to have proper sediment bearing pressure estimates to ensure that whatever these offshore structures are built, they are built safely and securely to prevent any damage or failure due to excessive pressure or settlement. Thus, overall, understanding this sediment bearing pressure is crucial for understanding the safety and stability of structures and preventing costly and dangerous failures. Such structures are vital considering the economic growth and strategic importance. In fact, the knowledge of initial sediment bearing pressure estimates is necessary during the initial design phases of a particular project. May not only be offshore, but any construction over an inland water body, say a particular dam or a bridge or a sea link. So again, this estimate would be crucial in the initial design phases, but it is to be noted that the awarded authority or the contractor of the project would not have the capacity, resources, or the expertise to conduct such detailed surveys for these bearing pressure estimates. Thus, we'll be going through various case studies also in this module, which would highlight the need of a comprehensive database for the sediment bearing pressure in order to have better accessibility to the third party contractors as well. Again, understanding where the sediment bearing pressure is also crucial. One of such areas is when the natural gas hydrate bearing sediments are being considered, because these natural gas hydrate bearing sediments are considered promising energy sources because of its considerable resource and high energy density. And with rising technology, there has been a growing demand and the growing global energy demand. There has been more commercial these national natural gas hydrate exploitation, and for this we need to have proper analysis of the mechanical and the geotechnical characteristics of these hydrate bearing sediments, because again the various parameters which are influenced by, like say, the hydrate saturation, effective confining pressure, sediment composition, the temperature and the pore pressure, all of this kind of mechanical behavior needs to be understood in order to have proper mechanisms and to have safe operations of this gas, of extracting gas to these sediments. Else it would lead to a lot of settlement, landslides, triggering potential failures, which may be drastic when we consider the economic potential of these resources as well. The sediment bearing pressure is also significant in the design and strength of the structural foundation of any tunnels as well. It is utilized to calculate the depth of the foundation, the depth of underwater tunnel systems, and the profiles of the tunnel cross sections also. So, for example, there was this tunnel which was built over the Xiang River in Changsha, China. So, the tunneling approach founded on such concerns because the overburden of the tunnels would consist of the sludge strata, ground gravel strata, and various weathered state of soil. Thus, a minimum overburden design method was to be developed, and in this, sediment bearing pressure was a crucial parameter. Now, the sediment bearing pressure also has a lot of application when we come to the offshore windmills for offshore energy. In fact, research data shows that the foundation investment accounts for around 20 to 30% of the cost of an offshore wind turbine, which leads to higher cost for offshore wind power than the onshore ones. Therefore, selecting the suitable type of foundation for offshore wind turbines is crucial in developing any kind of such wind farms. Also, the calculation of the foundation's bearing capacity would be based on the compressive strength of the soil or the rock strata present on the seabed. Also, the weathering effects and the hydrodynamic effects lead to the weakening of the bearing pressure, and that needs to also be understood in order to have a proper safe design. There, the foundation is also subjected to long-term cyclic loads, which causes the seawater to erode the rock and the foundation, thus reducing the ultimate bearing capacity. And as of now, there is no suitable rock mass classification for like evaluating this quality of like bedrock or any theoretical method for accurately calculating the ultimate end bearing capacity. So the acoustics can also play a major role in this. Then lakes can also be used as basins to investigate the various cases of slope stability under the various static and dynamic loading conditions. So a lot of studies have been conducted in the geophysical, sedimentological, and in situ geotechnical methods to discuss the control of physical and geotechnical properties for the slope stability. There are various studies which present significant advances in understanding the slope stability and what are the challenges in determining this physical and geotechnical properties. And if we consider the slope stability, the acoustics can play a major role in aiding the calculation of sediment bearing pressure to derive, as you can see in the figures, we can have slope stability, this kind of graphs. Then, apart from that, the crucial as sediment bearing pressure is also crucial in determining a bridge's safety and settlement, and to determine the foundation's depth. So there would be oil rigs and other, as I mentioned, there are a lot of bridges over rivers or any particular sea regions, and the foundation work requires detailed design. The settlement also be monitored every year during the flood cases of such construction. Protection measures would be taken accordingly. Also, the local erosion around the bridge's abutment would lead to bridge failure as well. A routine inspection is also required for any kind like maintenance for such bridge structures. So, thus, like the segment bearing pressure plays a crucial role in the foundation design. Similarly, there have been a lot of failure of bridges, as there have been like the Higashikobe Bridge and Akashi Kaikyo Bridge that have been destroyed by this like due to various hurricanes or due to sediment related problems. Again, when we consider the Mumbai Worli Bandra sea link, they also required major engineering solutions to the problems that they faced because of the highly variable geotechnical conditions at the foundation bed. And for this, thus, for any type of construction, this sediment bearing pressure estimate would give a proper initial understanding of what kind of design methodology can be implemented, what kind of foundation design can be done, and what kind of pile testing can be done. Similarly, we see that the ports they act as a primary source of trade and commerce, which handle approximately 95% of volume and 75% of value of India's external commerce. And again, there is this the port organizations need to adopt this modern technology like the more computerized information systems, GIS techniques, the acoustics, in order to have their proper expansion operations as well. So for offshore port related structures, all again the sediment bearing pressure would play a crucial role in any of the expansion of the ports and other of its related operations. Then coming to the freshwater systems, extreme sedimentation rates are exhibited in the Indian river systems. Again, the presence of riverbed sediment characteristics does not rule out the possibility of the various sediment mass movements, which leads to various hazards. And now, proper assessment can lead to settlement of the bridges, as you can see in the image. This can lead to a loss of infrastructure and can have social and economic impact as well. There can be failure of dams due to excessive bearing pressure estimates. Thus, the sediment bearing pressure is not only crucial in the offshore structures, but in the freshwater system, they also have a crucial role to play. But again, so this calls for utmost importance to develop a cross-disciplinary knowledge base and to investigate the sediment deterioration, the deformation of sediment, and slow failure processes to have a proper understanding of these processes. Now, regarding spatial and vertical resolution of data collection, the available data sets of the bearing pressure, there are very less such types of data sets and frequently lack detail. At the same time, the disturbance of core samples via the conventional in situ methods contribute to incorrect interpretations and simulations. Thus, there is a need to establish an end-to-end link between geophysics, geotechniques, these acoustics, which can lead to a proper understanding of the sediment bearing pressure. For this, we can use the 2C to understand 2 shell concept as well, which we'll discuss in the next submodule. With this, I'll end the discussion here. Thank you.